So, good morning, students. Hopefully, audio video is okay. Please, anyone reply.
Yes, sir.
So, welcome in next lecture of Math F242 Operation Research. So, before the in last lecture, we have seen the application of the simulation in supply chain. Now, the application of simulation for the queuing process. So, we have the discrete event simulation of single server queuing system. So you can extend for the multiple server also, but here I will demonstrate only for the single server. So what is your objective? Objective is to estimate the LQ, WQ means expected number of customers in the system in the queue, waiting time of the customer in the system and in the queue, or proportion of the time server is busy. So you can say P naught star. BG means it is the ideal. BG means 1 minus P naught cap. So cap because we are estimating the LLQ, WWQ and P naught. So through the simulation, we are estimating these performance measures. So you know that for simulating any process, first we require the events. So here we are defining some random variable. So interarrival time IAT is a random variable. So you can say it is continuous random variable having the CDF capital F. Similarly, the service time is also continuous random variable having CDF G. And maximum time we are taking for the simulation T max. Means up to what we have to simulate, we have to generate the customers, we have to give the service to the customer, generated customers, and up to what time we have to compute the performance measures. And it is assumed that there is no customer in the system initially. There is no customer in the system initially. So you can say it is the case first. Then after we have the case second. There are some customer. There are some customer in the system initially. So it may be one, it may be two, it may be n. So that is the another case. So as I have told you in the first lecture of the simulation that before starting the simulation process, we have to decide the variables. So here we have the some variables, time variable. We denote it by the capital T and it is the clock time. So always it start from 0 to the T max, because up to the T max we have to simulate the system. So it vary from 0 to T max. Then we have the two counter variables CNA and CND. CNA denotes cumulative number of arrival and CND denotes cumulative number of departure. So CNA, it is nothing, it is the cumulative number of arrivals and cumulative number of departures. So it measure how many customers are joining up to that point of time. Then after we have the following three system state variable or state variable you can say, which define the status of the system. So NS, NQ, STS. NS stands for number of customers in the system at time T. NQ stands for number of customer in the queue at time T, and is STS denote the state of the server at the time T. So server can be of two state, either the busy or idle. So when server is idle, we say STS is equal to 1. When server is busy, then we say STS is equal to 0. From here, we can have the following three output variable: CWTS, CWTQ, CIDT. CWTS stands for cumulative time spent all customer in the system up to the time t, means cumulative waiting time in the system. CWTS stands for cumulative waiting time in the system. Similarly, CWTQ stands for cumulative waiting time in the queue, and CIDT, it is the cumulative idle time up to the time t. So when the server is idle, right, at that time we have to accumulate or add or sum up. So these three are the output variable. So from these three output variable, we compute the following estimation. Actually, we have to estimate the following estimation, that is the LLQ, WWQ, and P naught. So from these output variables, CWTS, CWTQ, and CIDT, we compute those estimation. So these are some definition of the variable. Anything you want to re-explain? Any variable? If as per use, I will again re-explain. But at this point of time, if you want any for any variable re-explanation, I believe there is no doubt. Now, as I've told you that in every simulation process, these variables, state variables, counter variables, output variables, all variables change, right? Change through the events. So we have to generate the events, right? We have to generate the events. So for generating in case of the queuing system, we have the following events. So we have the two type of the events only: arrival and departure. So here we have the following time: NAT, NDT, and NET. NAT stands for scheduled time of the next arrival. Means next arrival time. NAT stands for the next arrival time. Means it gives you the information when the next customer arrive. Next arrival time. Similarly, NDT stands for the next departure time. Next departure time. So next departure time, so it measure when the next customer depart from the system. Clear? Then we have the NET. NET is nothing. It is the next scheduled time, means, or you can say next event time. Scheduled time of the next event. So next event can be either the arrival or departure or the Tmax. Tmax means end of the simulation time. Whatever we have the Tmax, so at the Tmax we have to stop the simulation. So in queuing system, next event can be either the end of the simulation due to the Tmax, or it may be the arrival due to the NAT, or it is the departure due to the NDT. So here we have the flow chart for the simulation process. So I will discuss one by one all these things. So this is the flow chart. Right. So after having the simulation process, we can estimate the P naught by the CIDT, by P naught by the CIDT upon Tmax, L cap CWTS upon Tmax, LQ cap CWTQ upon Tmax, W cap. Why we are writing the cap? Because we are estimating these values. CWTS upon CNA and WQ, CWTQ upon CNA. So we these are the some estimation. So now let us see what is the algorithm. So here we have the algorithm. Means I am saying everything depend over the event. So means if we have the three cases, NET is equal to Tmax, right? NET is equal to Tmax. If the next event time is equal to the Tmax. So when this time is possible, when this time or when this event is possible, when the Tmax, please listen carefully, when Tmax is less than equal to NAT and NDT. If Tmax is less than equal to NAT and NDT, then always we take the Tmax first. Means if we have the situation Tmax is equal to NAT is equal to NDT, then you have not to take the arrival and departure. You have to take only the Tmax. You whenever the Tmax is equal to NAT and NDT, at that time you have to take only the Tmax. If Tmax is less than NAT, then you have to take the Tmax. When Tmax is less than NDT, then also you have to take the Tmax only. When all are equal, then also you have to take the Tmax. So when the next event time is equal to Tmax, so next next event will be the end of the simulation. End of simulation. So when we have to end the process, at that time you have to update the output variable. So update output variable means update CWTS, CWTQ, CIDT. So you have to update the output variable, then estimate the performance indices. Then estimate performance performance indices. Performance indices. So this is the case first. This is the case first. Now, what is the case second? NET. NET is equal to NAT. When the NET is equal to NAT, when NAT is strictly less than Tmax, when the NAT is strictly less than Tmax and NAT less than equal to NDT, then you have to take the NET as a next event. So when you take the NAT as a next event, it means event will be the arrival. Event will be the arrival, and due to the arrival, cumulative number of arrival will increase by 1. CNA will become the CNA plus 1. CND CND will remain the as it is. There is no change in the CND. Then NS, number of customer in the system, that will increase by 1. Due to the arrival, that will increase by 1. NQ will also increase by 1. Or in a practice, you write it as a NS. NQ is nothing, it is the NS minus 1 when NS is greater than 1. When NS is greater than 1, then we say nq is what? Ns minus 1. Otherwise, it is 0. Means when ns is equal to 0 or 1. When ns is equal to 0 or 1, then we take nq is equal to 0. Otherwise, it is always, because we are talking about the single server model. So when we have the single server, then right, when we have the single server, then only one customer is busy with the server. So number of customer in queue will be the ns minus 1. Then after, now important thing, whenever there is the arrival, we have to generate or one more thing, sts. sts will be the, whenever there is the arrival, so sts will become the 0, right? sts will become 0. 0 means it denotes the busy. Whenever there is a customer in the system, naturally the server will become the busy. So sts will become 0, and you have to generate next arrival time. Generate next arrival time. So what is the next arrival time? It is nothing, it is the current time. It is current time plus inter arrival time. Whenever there is arrival, you have to decide. Means if particular customer has joined, at that time you have to decide when the next customer will join. So it is the NAT is equal to T plus IAT. Now, at what time again you have to generate the arrival? Whenever there is no customer. Whenever there is no customer, that is updated ns is equal to 0. Whenever there is no customer in the system, at that time also you have to generate the arrival. Means whenever the ns is equal to 0, when ns is equal to 0, at that time also you have to generate when the next customer will arrive in the system. So at the time of the arrival, when whenever there is only one, whenever there is only one customer, there is only one customer, that is updated ns is equal to 1. If the updated ns is equal to 1, at that time you have to generate ndt also, next departure time. Because when the first customer arrive, at that time you have to generate when this customer will depart. So it is nothing, it is the t plus service time, current time plus service time. So the first customer will depart after taking the service. So whatever the current time plus his service time will give you the next departure time. So whenever we have the arrival, at that time you have to generate the following things. Next event can be the ndt. So when the ndt is possible, only when ndt is less than nat less than tmax. If ndt is equal to tmax, then you have seen we have to consider the tmax. When ndt is equal to nat, then also you have to consider the arrival only, right? For considering the ndt, always the ndt must be strictly less than nat, strictly less than the
T max, then only you have to consider the NDT. So due to the NDT, NDT means next departure time. So due to the NDT, what will happen? CNA will remain as it is because CND measure the cumulative number of departure. So CND will be increased by 1. CND will increase by 1. Number of customer in the system will decrease by 1. And similarly NQ also decrease by 1. Right? Or basically it is nothing. It is the updated NS minus 1. Updated NS minus 1. Right? When NS greater than 1, otherwise it is 0. When updated NS is equal to 0 or 1. Then STS. STS will become 1. Ideal when when old NS is equal to 1. When old NS is equal to 1 means old NS is equal to 1 means there is one customer and you have provided the service. So whenever you have provided the service, server will become the ideal. Otherwise, it will remain 0. Right? Otherwise it will remain 0. 0 means busy. Then after, so whenever we have the departure, at that time you have to generate the next departure also. Generate NDT. So what is the NDT? It is the T plus ST, means current time plus service time. So means as you have completed the service for one customer, immediately you have to say when the next customer will depart. That is the T plus ST. So whenever whenever updated NS is equal to 0, what is our requirement? Means now there is no customer. So when there is no customer, at that time our first preference is to generate the arrival. So under that consideration, because there is no customer, you cannot depart the customer. At that time, always you have to consider the NDT as a infinity. If you are making computer program in Python or in any language in MATLAB, so infinity you cannot define. At that time, we will take it as a T max plus 1, because at the T max your clock will stop, your simulation process will stop. Never you can achieve the T max plus 1. So T max plus 1 also behave like a infinity only. So theoretically we write the infinity, but for the computer program you can try this algorithm in Python also if you have the interest in programming. So at that time you have to consider the NDT is equal to T max. When the updated NS is equal to 0, the means due to this consideration, due to this assumption, forcefully we are considering that next event is the arrival. So here we have seen, means in starting we have seen that NET is what? NET is the minimum of NAT, NDT and Tmax. Minimum of NAT, NDT and Tmax. So it can be anything. It can be Tmax, it can be NDT, it can be NET. So when it is a Tmax, when it is less than equal to NAT as well as NDT. When it is the NAT, when it is less than equal to NDT but strictly less than Tmax. When it is the NDT, when strictly less than NAT and strictly less than Tmax. Then we say it is the NDT. So in this way, so here we have the some state variable, right? From here we update the output variable also. So output variable, how we are, what is the cwts? Cwts stands for the cumulative waiting time in the system. So it is nothing, it is the cwts of the previous time plus number of customer in the system in the previous time plus difference of time. Difference of time means it is nothing, it is the current time, current time minus previous time, minus previous time. So this is the formula for the right cwts. So with this cwts, or with this formula, we update the cumulative waiting time in the system. So cumulative waiting time in the system is nothing, it is the cumulative waiting time in the queue, in the system, plus ns into current time. Similarly, CWTQ. CWTQ is what? It is the CWTQ, old CWTQ plus NQ into difference of time. So this will become CWTQ is equal to CWTQ plus NQ into difference of time means current time, current time minus previous time, previous time. Then after another output variable is CIDT. CIDT means cumulative idle time. So what is the cumulative idle time? When the server is idle, when STS is equal to 1. So it is CIDT plus STS, STS into difference of time. Difference of time, that is the CIDT is equal to CIDT plus STS. STS can take the value either the 0 or 1. 1 is 1 for the ideal, 0 for the busy, right? Into difference of time. So current time minus previous time. Current time minus previous time. So in this way, we have the CWTS, right? CWTS, CWTQ, and CIDT. And after having the knowledge of these output variable, you can compute, you can estimate the following performance measures: P naught, L, LQ, W, WQ, using this formula. Using this formula. So for the single server model, we have to make the table, right? We have to make the table having the following heading. So first one is the T. Then after we have, right, first one we have to we have the T. Then after we have the current event. Then we have the CNA. Then we have the CND. Then we have the number of customer in the system. Then we have number of customer in the queue. Then we have STS, CWTS, CWTQ, and then CIDT. Then after we write the column for the arrival. So arrival means inter-arrival time, inter-arrival time. Then we generate the inter-arrival time. Then we generate the NAT. And before the inter-arrival time, we have to consider the random variable for the arrival. So random variable for the arrival we denote by the UA. Then after we write the column for the service. So random number for the service. Then we generate the service time. Then we generate the service time. Then next departure time. And minimum of NAT and NDT will give NDT and Tmax will give you NET, and NET will give you NE, right? NDT will give you the NE. So so here we have the heading, right? So let us discuss all these heading one by one. So what is the T. T is the current time. T is current time. So means clock will start from 0 to 0 to T max. Clock will start from the 0 to T max. So we have to update. We have to update so time continuously. So it is the previous time plus next event time. It is equal to the previous time plus next event time. Or you can say more clearly, Ti is equal to Ti minus 1 plus Net I minus 1. Net I minus 1 means what is the next event in the previous row. Then after we have next heading is the current event, right? So it is the current current event. So current event means CEI. It is nothing. It is the next event of the previous row. It is next event of the previous row. Then the CNA, cumulative number of arrival, cumulative number of arrival at that ith row. So it is nothing. It is the CNA of I minus 1 plus 1 when current event, when the current event is the arrival. When current event is the arrival, it remain Ci minus 1 when current event is departure or Tmax. Then there is no increase in the CNA. Similarly, CND, CND means cumulative number of departure. So cumulative number of departure will increase by 1 when the current event is equal to departure. Otherwise it will remain same if the current event is either the arrival or Tmax then the CND will remain CND. Similarly, STS current can be busy, can be ideal or busy. 1 stands for the ideal and 0 stands for the busy. So when the STS is ideal, so STS is ideal whenever, right? STS is ideal whenever the NS is equal to NSI. NSI is equal to 0. Whenever there is no customer at that time, we can say that server is idle. When NSI is equal to when NSI is not equal to 0, then we say STSI is equal to busy. Then after we have to compute the output variable CWTS. So current CWTS is nothing. It is the CWTS of previous plus number of customer of the previous into difference of time. Difference of time, that is the DT. So difference of time is nothing. Current time minus previous time. Current time minus previous time. So NS of I minus 1 and CWTS I minus 1. Similarly, CWTQ, CWTQ will be the of the current time. It is the CWTQ of previous plus NQ of previous. Here we have not included the NS and one more thing. At this place we have to include the NS also. What is the NSI? Then after we have to. What is the NSI? NSI is the NSI minus 1 plus 1 when the current event is the arrival. It is the NSI minus 1 when the current event is departure. It is equal to as it is when the current event is T max. When current event is the T max. When current event is the T max, at that time NSI will remain the as it is. And what is the NQ? What is the NQ? NQ will be here I am writing, right? So what is the NQ? NQI is nothing. It is the NSI minus 1. NSI minus 1 when when NSI is greater than, when NSI is greater than 1, then you have to take this. Otherwise NQ is equal to 0. Other when NSI is equal to 0 or 1, then NQ is equal to 0. Otherwise we take the NQI as a NSI minus 1. So after having the knowledge of the NS, number of customer in the system, we can update the output variable CWTS, CWTQ. So it is the CWTQ. So NQ at I minus 1 into difference of time, that is equal to CWTQ I minus 1 plus old NQ into current time minus previous time. Current time minus previous time. Similarly, CIDT, CIDT of the current event time. So it is the CIDT of previous time plus STS of the previous time into difference of time. So it is equal to CIDT of previous time plus STS of previous time into current time minus previous time. Then after we have to generate the arrival, means generate arrival generate arrival generate arrival means you have to consider the random variable for the arrival, then you have to generate the inter arrival time, and then you have to compute the NAT. NAT is what? It is the current time plus IAT. Current time plus IAT will be the NAT, next arrival time, for the current time. And when we do this process, when we do this process, when the current event is arrival, when current event is arrival, then we do this process. When the updated ns is equal to when updated ns is equal to departure, or you can say more clearly, when current event is departure, and and number of customer in the system ns is equal to 0, then also we generate the next arrival, right? Then also we generate the next arrival. So when we generate the departure, so we generate the departure when the current event is the departure, then we generate the departure. How we can generate the departure? For that we require the random number for service, then we compute the service time, then NDT, next departure time, is equal to the current time plus service time, current time plus service time. So when we generate the departure, when the current event is departure, and when the current event is arrival, and and NSI is equal to 1, if it is the first arrival, if it is the first arrival, current event is arrival and it is the first arrival, then we say it is equal to then also we have to generate the departure. Clear? Then we have to generate the NET. So what is the NET? It is the minimum of NAT, NDT and Tmax. So And what is the next event? Next event is nothing. It is the event of NETI. Whatever the next event time, at that time, whatever we have defined the event, so we write the NE as a like that. So this is the algorithm for the queuing system. So let us understand all these things through the example. So hopefully, if there is any confusion, that will clear by the example. Still, if you want to ask, you can ask anything you want to clarify from the algorithm. If anything you want to clarify, anyone?
Sir,
Yes.
sir, can you explain the NET in case 2?
NET in case 2 no.
No, sir, NET.
हाँ, यहाँ पे जनरेट अराइवल में
Yes, sir.
हाँ बताओ क्या है इसमें केस 2 में when the current event is arrival then you have to generate the arrival what is the next arrival and when the current event is the departure, right? Departure. So at that time when there is no customer, at that time you have to generate the when the next arrival will come when there is no customer. And for example, you have to run your system for the 10 minutes. At the 6th minute now system is empty, so you have to decide when the next customer will come, either
Yes, sir.
at the 6:10 or at the 6:15 or at the 6:20, when the next customer will come, because you have to continue your simulation process up to the 10 minutes,
Yes, sir.
right? So that is the, because after taking the service now customer is means system is empty, ns is equal to this. So at that time you have to consider, the ndt as a infinity also. Any other doubt? So let us have this question. The distribution of inter-arrival time in a single server model is t is equal to 1 to 3. It is the inter-arrival time is given to you. Corresponding probabilities are given to you. That is the PDF. PDF is given to you, and the distribution of the service time s 1 to 3. Right. This is the value. Corresponding PDF is given to you. Right. Corresponding PDF is given to you. So from this you can say what is the ft cdf. It is the 0.25, it is the 0.75, and it is the 1. So what is the scheme for the discrete distribution? You know what is the scheme: 00224, 25274, 75299. That is the scheme. If the random number lie between this, so we consider the corresponding inter-arrival time. Similarly, CDF for the service time FS will become the 0.50, then 0.75 and 1. So range will be 00249, 50274 and 75299. So if the random number for service lie in these interval, corresponding service time we have to take. So simulate the system under the following heading. We have already seen the headings: T, current event, cumulative number of arrival, cumulative number of departure, number of customer in the system, number of customer in the queue, cumulative waiting time in the system, cumulative waiting time in the queue, state of the server, cumulative idle time, random number for arrival, inter arrival time, next arrival time, random number for service time, next departure time, next event time, and next event. For the tmax is equal to 5 unit, you have to simulate for the 5 unit using 2-digit random number 112047689062 and 35 to generate arrival, and 15862042113648 to generate the corresponding service time. If there is no customer initially, this is the case first. Case first. Also compute P naught cap, W cap, and WQ cap. So you have to this generate. So in this case, our clock will start. Our clock will start from the t is equal to 0. Current event is the start. Current event is start. So initially there is no customer. So CNA is equal to 0 because there just you have started your process. So CND will be the 0. Initially there is no customer. NS is equal to 0. NQ is what? NS minus 1. So it is 0 only, because just now you have started your system. So CWTS is also 0, CWTQ is also 0, because presently there is no customer. Server is idle. And cumulative idle time is equal to 0. So when there is no customer, always your system will start with the first arrival. So first arrival means we take the first random number for the arrival. So 11. So when we have this 11, so 11 will lie in this range. So you can say inter arrival time is equal to 1. So when the IAT is equal to 1, IAT is equal to 1. So NAT is what? Current time plus IAT. So current time is 0. So 0 plus 1 is equal to 0. When it is the first customer, always we take the NDT as a infinity. For the first customer, after the empty, for the first customer, because when there is no customer, you cannot say when it will go. It will go after the infinite time. So need not to take the random number US or ST. NDT you have to take the as an infinity. So what is the NAT? NAT is the NAT is what? Minimum of NAT, NDT, and Tmax. So NAT is 1, NDT is infinity, Tmax is 5. So minimum is 1. So it means next event is the arrival. So this next event will come at the 1, because it is given to you. Next event will happen at the 1. So at the 1, next event is the arrival. So current event is the arrival. So due to the arrival, cumulative number of arrival will increase by 1. CND will remain same. Now number of customer in the system will become 1, and number of customer in the queue will be the 0, because whatever the first customer, that will join directly to the server. So NQ will be equal to 0. Now CWTS means old CWTS plus old NS into difference of time. So it will remain 0. Similarly, CWTQ means old CWTQ, old plus old NQ into difference of time, 1 minus 0. So it also will remain the 0, right? It will remain 0. Then after STS, because there is a arrival, now STS will become BG. Now CIDT means old CIDT plus old STS, that is the 1 into difference of time. Means 1 into 1 minus 0, that is the 1. Now it is the arrival. So when there is the arrival, I have told you we have to generate the next arrival. When it is the first arrival, then we have to generate the departure also. When it is the first arrival, at that time we have to generate the departure also. So next, so here means next random number after 11, next random number is the 20, and first random number for the departure is the 15. So you can see from here, depart when it is the 20, so 20 also lie in this interval. So it means next arrival time is the interarrival time is 1, and 15 lie in this interval. So here also the service time is what? Service time is, right? So here the service time is some misplaced हो गया ये क्या? So service time is the 1, right? So here you can see interarrival time is 20, means random number is 20, so interarrival time will become the 1. So NAT is what? Current time plus IAT. So current time is 1, current time is 1 plus 1, that is the 2. US is what? 15. So service time will become the 1. So current time plus service time will give you the next departure time, that is the 2. So here we have to take the minimum of NAT, NDT and Tmax. So here it is what? 2, here it is what? 2, here it is 5. So minimum is NAT plus NDT. So when we have the tie, I have told you always we have to take the arrival. So here we take the arrival. So at the clock time 2, at clock time 2, we have to consider the arrival. So due to the arrival, CNA will increase by 1, CND will remain as it is. Now number of customer in the system will be the 2, number of customer in queue will become the 1. Now CWTS. CWTS is what? Old CWTS plus old NS into difference of time. Into difference of time. That become the 1. Then CWTQ. CWTQ is the old CWTQ, old CWTQ plus old NQ into difference of time. Then because there is a customer, it will, server will remain BG, so it is a BG. Then CIDT is the old CIDT 1 plus old STS 0 into difference of time, that will become the 1. And due to the arrival, we have to generate the next arrival. We have to generate the next arrival. So next, for the next arrival, we are taking, for the next arrival we are taking the next random number. So next random number after 20 is the 47. So corresponding to 47, it is misplaced, otherwise corresponding to 47, interarrival time is the 2, right? Interarrival time is 2. So when the interarrival time is 2, so here we take the interarrival time is 2. So next arrival time will become the 2 plus 2, that is the 4. And there is no need for generating the departure because next departure time is already there. So it is the 2. So next event time is the minimum of NAT, that is the 4, NDT 2, Tmax 5. So minimum is 2. So here we consider this 2. So when we consider this as a 2, so next is the departure. So when at the 2 we have the departure. So due to the departure, CNA will remain as it is, CND will increase by 1, NS will decrease by 1, NQ will become the 0, CWTS, CWTQ, CSTS and CIDT you can update. But when there is a departure, you have to generate the next departure time. And previous arrival just till now not happened, so we have to consider as it is. So minimum NAT is the minimum of NAT, NDT and Tmax. So 4, 5 and 5. 4, 5 and 5. So minimum is the 4. So NAT is equal to 4. Next is the arrival. So at the 4 we have the arrival. Due to the arrival, CNA will increase, CND will remain as it is, NS will increase, NQ will increase. Then we have to update the CWTS and STS. When there is the arrival, you have to generate the next arrival. So next arrival, next number is the 68. Corresponding to 68, we have the interarrival time 2. So next arrival time will become the 6. So here we have the 6, 5 and 5. So whenever we have the 5 and 5, at that time you have to take the Tmax, right? Whenever we have the Tmax, so you have to end the simulation. So when you have to end the simulation, at that time you means from the CIDT you can estimate the following performance indices using the following formula. So CIDT you can see here, the CIDT is what, right? At the 5 we have to end. So at the 5 and we have to end, just we have to update the CWTS, CWTQ and CIDT. At the end, you have to update only the CWTS, CWTQ and CIDT. So now this is the final CWTS, final CWTQ and final CIDT. So using this formula, you can estimate the following performance measures. So that's all for today. Yes, any doubt? It is little lengthy thing, so that's why I have to take the few more minutes. Right. So tomorrow means in next class, I try to re-explain all these things. If you have the doubt, you can ask now. The person doubt, the person Mazumdar.